In this video, we're going to have a look at solving simultaneous equations. Often you're given these equations as linear equations like this, where you've got a certain number of x plus or minus a certain number of y equals a number. And if you've got two equations like this, the best way of solving these is by elimination. Now the first thing we need to do to eliminate either the x or the y from our equation is to transform one or both of these equations so they have the same number of either x or y. And in this case, I'm going to pick to have the same number of x. It's really good practice to number your equations. So in this case, I'm going to number them 1 and 2 so I can refer to them later. What I'm going to do here is I'm going to take this first equation, equation 1, and I'm going to times it by 3. I'm going to times it by 3 because the x coefficient of the second equation is 3. We'll come back to that later. So 3 lots of 8 is 24, x, plus 3 lots of 5 is 15y, equals 3 lots of negative 28 is negative 87. Now, we multiplied the first equation by 3 because the coefficient of x for the second equation was 3. So in the same way, we're going to take the second equation and we're going to multiply it by 8 because this first coefficient of x was 8. That gives us 3 lots of 8 is 24, subtract 8 lots of negative 7 is 56, y equals negative 16, which is 8 lots of negative 2. Now you notice we've had the desired effect because we've got the same number of x's here. And what we essentially do here is column subtraction. We're going to subtract, in this case, equation 1 from equation 2. So we're just going to make a quick note of that. Now, 24x, take away 24x, leaves us with 0. We don't really need to write that, but we'll write it just for reference. 15y, subtract negative 56y, gives us 71y, equals negative 87, subtract negative 16. So negative 87, add 16, which gives us negative 71. Now you can see there's two 71s here, so it's going to be relatively easy. I'm going to divide both sides by 71. But very quickly you can see y equals negative 1. So that's the first part of our solution. We'll put a box around that just to make it really clear to us what that was. Now we've got the value of y, we need to find the value of x. So we're going to go back to our original equations, and we're going to use, in this case, equation 1. Now, we know that we've got 8x plus 5 lots of y. Now y we know to be negative 1, so 5 lots of negative 1 equals negative 28. And it's now just a matter of solving this equation in the normal way. So we've got 8x subtract 5 equals negative 28, and we add 5 to both sides, which gives us 8x equals negative 24. Divide both sides by 8, and we get x equals negative 3. That's hopefully the second part of our solution. So we've got x equals negative 3 and y equals negative 1. Now just to confirm that answer, we've used equation 1 to find x. We're going to use equation 2 to confirm. So we're going to use 2 just to put these numbers in, and we're going to do 3 lots of x, 3 lots of negative 3, subtract 7 lots of negative 1. And if we work that out, that's negative 9, add 7, which is negative 2. And that's what we were expecting, so that's correct.